now we're going to talk about completing the square. And now if you look at this little table, it's showing you how to do the completing the square. So we're going to go straight to one of the examples. So number one, okay, on number one, we're trying to figure out a C value, all right? We're trying to figure out the last term that would make this a perfect square. Now to do that, we're going to have to, I'm going to write this on a separate piece of paper because I don't want to scrunch this up. So to figure out this problem, right, so this is problem number one. This is x squared minus 10x plus c. So it turns out that to figure that out, what you're going to have to do is you're going to have to, c is going to be equal to negative 10 over 2, and then you're going to have to square that. So notice that I'm grabbing the second term, which in this case is what they call the b term on here, and then I'm going to divide it by 2 and then square it. Now when I do that, that's going to give me a negative 5, and if I square that negative 5, that's going to give me 25. Now I'm going to replace that c with a positive 25. Okay? Now the next step is they want us to write this trinomial, and it's called a trinomial because I have three terms right here, as a perfect square. Now to write this as a perfect square, the thing you got to think about is if I were to factor this, all right, so I'm factoring this. Remember, positive 25 means I have the same term, negative, and the middle means I have a negative and a negative. So I'm looking for factors of 25 that add up to 10. In this case, that's 5 and 5. Okay, now the reason this is going to be called a perfect square is I can rewrite x minus 5 and x minus 5 as x minus 5 squared. Okay? So that's basically all you have to do. Now, I'm going to go over to example number 2. And in example number 2, let's see, I have x squared plus 60x plus c, and c is equal to 60 divided by 2, all of that squared. So that's going to be 30 squared, which is going to be equal to 900. Okay? Now, I'm going to rewrite this as x squared plus 60x plus 900. Okay? And then if I were to factor this, all right, this would be x plus 30, factors of 900 that add up to 60. Which I can rewrite this as this. Now please notice, if you want to write this faster, this second term is always going to be, you see how I have a 30 here and I end up with a 30 in the factors? Or in this one, for example, I end up with a negative 5 and I end up with a negative 5 here. That's how you're able to do that without actually even having to factor it, right? So on the second one, on the third one, I'm going to have a fraction, but not to fear. Alright, so again, c value is going to be equal to negative 3 over 2. It's basically the middle term divided by 2. And then you're going to square that. Now, when I square this, I essentially have negative 3 squared over 2 squared, which will give me 9 over 4. Okay, so this would be x squared minus 3x plus 9 over 4. Okay. Alright, and then now I'm going to have to rewrite this as a perfect squared, and I'm going to write it like this. Now I already know this, and the reason I was able to do this so fast without even factoring, remember, is because I'm just looking at the inside of this before I square it. So before I square it, I can write this as x minus 3 halves squared. Now remember that 3 halves times 3 halves is 9 over 4, and if I have negative 3 halves plus negative 3 halves, that's basically a negative 1.5 minus a negative 1.5, that will give me a negative 3. Okay, so that's how you do those. So now we're going to go ahead and move on to how to solve this. All right, so we're going to use the method that we just found by completing the square to solve some of these. So I'm actually going to write this on an extra piece of paper here. It's a pretty simple concept once you get it. All right, so number 7. All right, on number 7, what we're going to do first, before we complete the square, we solve the equation by completing the square, is that we're going to add the 5 to this side, okay? So we have a y squared. Well, let me rewrite the whole equation, then I'll show you how to do it. So again, this is 7. I'll put it over here. All right, so number 7, I'm going to start off by adding the 5, or the constant number, to the other side, okay? Now what I'm going to do after that is I'm going to do the completing the square on the left side. Okay, so remember that this term that I'm going to have is going to be a negative 4 over 2 squared, which is going to be, let's see, negative 2 squared, which is going to be a 4. Okay, so I'm going to have a y squared minus 4y plus 4 is equal to 5. Now, before I go on, I can't just randomly add a number on the left side and not add it to the right side. So again, whatever I do to the left, I have to do to the right side. Okay, so that's the trick to this. After you do the completing the square, make sure that whatever value you got here, you have to add it to this side and that side also. Okay, so this right here, if you remember how to complete the square, if you factor, so I'm going to factor one more time so you can see it. But after that, I'm not going to do that anymore. So this will be y minus 2. Y minus 2. Factors of positive 4 that add up to negative 4. And this is 9. So this will be y minus 2 squared is equal to 9. Alright, so the nice thing about using completing the square is that now this is actually a very simple problem. To solve this, all right, what I'm going to do next, I'll need to get rid of that square value. So to get rid of that squared, I'm going to do the inverse of that, which is a square root. So I'm going to take the square root of both sides. So this is going to be y minus 2. That just gets rid of the square. Now the square root of 9 is going to be plus or minus 3. All right, so remember, you're going to have two answers. Don't forget that when we're doing all these questions, especially when we're solving for something like this, I'm really just asking you, especially because it's equal to 0, where does this, in this case, cross the y-axis or the x-axis normally? Okay, so I'm going to have two answers for this. So I'm going to add 2 to each side. So I have one answer that's y is equal to 3 plus 2, which is 5. And I have another answer, which is y is equal to negative 3 plus 2, which is negative 1. Okay, so that's basically how you do a problem, solve a quadratic using completing the square method. So that's it for that part right there. Let's go ahead and look at number, excuse me, let me look through this. Okay, so again, these are your two answers. You got this one and that one. Two solutions. All right, let's go ahead and take a look at number 8. Let's see, I'm just making sure I'm not taking too long. Yeah, let's go ahead and look at number 8, I guess. And then I'm going to leave 9 up to you. So, number 8. All right, what I'm going to do with number 8 is the same thing I did with number 7. I'm going to write it. Now, this one I'm going to go faster. Alright, so in this one, I'm going to start off by, remember, adding the 65 to that side. Alright, and now I'm going to grab this term right here, divided by 2, and square it. Now, negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So I have x squared minus 8x. Let me write a middle step here. This will be negative 4. This will be square. This will be 16. So it doesn't change anything. I just want to write that so you can see what I'm about to write next. So we have here a plus 16. And remember, whatever I do to the left side, I have to do to the right side. Okay. Now this is going to be 81. Now on this side, remember, I can write this as a perfect square. And this would be x minus 4 squared. Remember, if you don't know how we got that, factor it, and you'll see that I got this. But remember that this number came from here. This is 81. And then now to get rid of the square, I am going to take the square root of each side. So this, I'm left just with an x minus 4 here and a plus or minus 9 here. And then now I'm just going to add the 4 to the right side. Now remember, when I add the 4, I have x is equal to 9 plus 4. And x is equal to negative 9 plus 4. So this is going to be 13, and this one's going to be equal to negative 5. Okay? Now if you want to see if you can do this yourself, let's take a look at this one right here. The one with the W. Right, this one, if you want to do it on your own, the answer should be 3 and 7. So W should be equal to both of those. So again, see if you can get that. Now we're not going to do the middle number, so the ones to start with something other than a 1 here. So if you have a leading coefficient, I would honestly say that you can either try to factor, if you can, using either bottoms up or the string factoring, or you can just use the quadratic formula, which we talked about in the previous section. So we're not going to do that. However, I'm going to do a couple that are a little bit different, like number 13. Okay, so number 13, let's go ahead and take a look. Alright. I'm going to write it over here because I don't want to mess this up too much. Alright, so 13, I have an x squared plus 4x plus 1. So really the method is not going to change. It's just going to have a slightly different answer. Alright, subtract the 1. So I'm going to start off by subtracting the 1 from each side. And then now I am going to do the completing the square method. Okay, so that's going to be a 4. So in this case, alright, remember I'm going to rewrite this, and I'm going to add a 4 to the left, and if I do it to the left, I have to add a 4 to the right. Alright, to write this as a perfect square, remember, you would have x plus 2. Okay, basically that same number that you got here. And this one right here would be a 3. And just like that other one, I'm going to take the square root of each side. And that's going to give me x plus 2 plus or minus the square root of 3. Right, and after that, very simply, I'm going to subtract the 2 from each side. Now, I cannot, unless I use a calculator, I cannot add those two. They're both numbers, but I cannot add them. So I'm actually just going to leave them like that. This is technically 2 answers, right? You have negative 2 plus the square root of 3, negative 2 minus the square root of 3. So this is actually my answer for that. Okay, let's see. If you want to do 14 on your own, I'll show you what the answer to 14 is. I remember 14 would be, well, I'll write you the question and I'll write you the answer. So if you want to try that, the answer for this one would be negative 6 plus or minus 4 square root of 2. I guess y is equal to that. So this is the answer for number 14 if you want to try that one. Alright, let's look at number 15. 15, it's interesting. Relatively speaking, of course. So on 15 we have, let's see, what do we have here? Okay. We have t squared plus 3t minus 8 is equal to 0. Alright. So in this one, first thing I got to do is I'm going to add the 8 to the right side and the left side. Add 8 to both sides, so I get this. Okay, now I'm going to grab that 3 divided by 2 and I'm going to square it. Now, this would be the same thing as squaring this and squaring this. So it's going to be 9 over 4. Okay, sort of similar to what we did at the front. So now I'm going to add that to the left and to the right. I'm going to add this 9 over 4 over here. And I'm going to add the 8 over 4 over here also. Alright, before I go on to add a fraction like this and a number, I'm going to have to multiply top and bottom by 4 here. And this right here, if I write as a perfect square. If you're not sure what to write right here, just look at what you wrote right here, 3 over 2. That should be this right here. If you're not sure that that right, square 3 over 2. If you square the 3 and then square the 2, you get 9 over 4. And if you have 3 halves plus 3 halves, that gives you 3. So that's a way to check yourself. Now this one right here, I have 32 over 4 plus 9 over 4, which is 41 over 4. Okay? So let's go back over here now. So I have t over 3 halves squared is equal to 41 over 4. I'm going to go ahead and take the square root of both sides. So this right here would be t plus 3 halves. This side would be the square root plus or minus of 41. Now the square root of 4, and I'll write it over here. That's the same thing as this over here. The square root of 4 is 2. So that's how I got this 2 over here. Right, last step is I'm going to subtract 3 halves from each side. Now it turns out I can't just do that in one step, so I'm going to write it as plus or minus 41 over 2 minus 3 halves. Now because I do have the same denominator, I have the choice of writing it like this, and really if you get to that point that would be the right answer, but I'm going to write it like this, negative 3, so notice I'm just switching places here, plus or minus 41, all of that over my common denominator, which is 2. Okay, so that one's basically as hard as you could possibly get on that part. Alright, so that's it for the using the method of completing the square. Now let's go to the back. Now this one, it's essentially like completing the square here, but easier in the sense that this is basically a square function. If you have 9, if you divide it by 2, if you have 81, if you have 18, you divide it by 2, you get a 9, and 9 squared is 81. So this is already a perfect squared. So this would be x minus 9 squared is equal to 49. This is on the back side of that. Then you take the square root of each side, kind of like we did on the front with completing the square. So this would be x minus 9 is equal to plus or minus 7. And then you're going to add the 9 to each side. So this is, you're going to get an answer that's 7 plus 9. You're going to get another answer that's 7 minus 9. Negative 7 plus 9, excuse me. So this would be 16. This is going to be equal to 2. Okay? So that's how you do that part. And then now, let me look at my worksheet here, and then we can move on. So that's how you do that. Now, let's look at another one. For example, in this one, if you're not sure how to write this as a perfect square, just grab that 20 and divide it by 2. And that should give you a 10. So in this one, you have x plus 10 squared is equal to 64. You take the square root of each side. And when you take the square root of 64, you get plus or minus 8. And then all you have to do is subtract the 10 from each side. And you're going to have two answers. One, this x is equal to 8 minus 10. You have another one that's negative 8 minus 10. So this would be negative 2, and this would be negative 18. So two answers right there. Okay, so on this one it might be harder to see if you will. And I'm trying to think about how I would explain this, because this one's a little bit more difficult. On this one, to write that it's a perfect square, that's a little bit different because you have a leading coefficient here. So this is a little bit different. Now this one, what I normally do is if you have a 4 here, I just think of the square root of 4, and that's a 2x. And then I think of the square root of 1, which is 1. So I have a 2x plus 1. Now if you're not sure that that's correct, if you're not sure that this is equivalent to that, then you can go ahead and just FOIL it if you like. That's equal to 16. And then now I'm going to take the square root just like I did before. So I have 2x. 2x plus 1 is equal to, excuse me, I haven't even taken the square root yet. I have that equal to plus or minus 4. So in this one you are going to have two equations you at least have to work out. So this one's equal to 4, and you have another one that's 2x plus 1 is equal to negative 4. Work out each one of them. You're going to get two answers. If you subtract 1 from here, you're going to get a 3. So you got 2x is equal to 3. And if you divide that by 2, you get 3 over 2. And on this side, if you subtract 1, you get a negative 5. So you get 2x is equal to negative 5. So x is equal to negative 5 over 2. Okay, so I hope that makes sense for that. So in essence, this is a lot easier to figure out what the square root is, or excuse me, what the perfect square is. So on this one right here, same idea. All right, I have 6x plus 1 squared. Okay, and we're going to set that equal to 18. So this one's a little bit different, but nonetheless, if I take the square root of each side, this is a little bit different because 18 is not a perfect square, so I'm not going to get a whole number for that. So just like we did in previous sections, I don't know why I wrote that. Just like I did in previous sections, I'm going to have to break down this 18 into prime factors and then simplify the radical. All right, so this one right here would just be 6x plus 1. Remember 18, I'm going to write it over here to the side. 18 is like 9 and 2, and 9 is 3 and 3. So this would be plus or minus 3 square root of 2. Okay? Then after that, I'm going to subtract the 1. On this side, I do have two answers, but I can write it all at the same time. I have 1 plus or minus 3 square roots of 2. And then I'm going to divide both sides by 6. So this is actually your answer for this one. Okay? Alright, on this one, if you have any questions on this one, remember if I take the square root of 9, I get a 3x. If I take the square root of 4, I get a 2. Now be careful on this one because the middle term is negative. That means that this also has to be negative, but if I take the square root of 4, that's 2, right? It has to add up to a negative 12. Alright. So again, you're basically taking the square root of the first, the square root of the last, and make sure that this sign matches with that sign. Okay. See if you can solve that one. If you can, then you should get two answers. One of them should be 0, and the other one is going to be 4 over 3. Okay. Now let's see if I want to do another one here. I really don't. But at least I'll write you what this should be. This should be 5x. Right, remember that? Square root of 16 is 4. And this sign is going to match up with that sign. So, alright, this is very similar to this one. Now 28 is not a perfect square, so therefore you're not going to have a whole answer for that. But if you get the answer should be negative 4 plus or minus 2 square roots of 7 over 5. Work this out, and I hope that helps.